Thanks for being here. My name is Wim de Kort, and you walked into the IoT session. So you can change your mind in case that's not where you want to be. A quick introduction. I've been around the FileMaker community for a while, and my work has taken me through many countries where I lived and worked. But there's a rumor floating around that may not be the reason that I move around as much as I do. I have the privilege of working at Soliant Consulting, where I can do what I really want to do, and that's mentor the folks that we have. It's a great team, and it's a pleasure to work with them. IoT, that's why we're here, right? And we heard the short version in the keynotes. Basically, the concept has been around for a while, right? This definition stems from 1985. And if we distill it down, it really comes down to the stuff that I highlighted in yellow, right? We're talking about devices that are connected, either with each other or with the internet or something else. And the devices can interact with their environment, right? So they can collect sensor information and they can manipulate their environment, right? Think of something where if the temperature goes above a certain set degree, we can open a valve, right? So they call that the edge, right? Where things really matter, where things really happen. That's where the devices live, and these devices are connected, interconnected, or connected with the internet. The Internet of Things is closer than you may think, right? It may seem like a very abstract thing, but it really isn't. This is a snapshot of all the IP devices in my house, everything that consumes an IP4 address. I had to cut it off a little bit, but as you go through the list there, you'll see that there's some IoT devices in there, right? There's some Nest cameras in there. There's my Sonos soundbar. There's a Roomba vacuum cleaner. All of these things are what we call the Internet of Things. So it is a lot closer than what you may think. And there's a good reason for that, right? These things are cheap and they can do a lot. So that makes them extremely handy and convenient, right? That's why we will see so many of them through our lives, right? So in our house, in our cars, everywhere we have Internet of Things. Some quick numbers, and numbers are always difficult, right? Because you can find many sources and they'll all say many things. But I want to show you these numbers, not to convince you that you absolutely need to get into IoT right now because of those numbers, right? That's not what I'm saying. But what I'm trying to say with these numbers is that you're very likely to come across something that is IoT related in your work. As you can see, we have roughly, say, 4 billion smartphones and devices out there, but we already have more than double that in IoT devices, and it's projected to grow exponentially over the coming years. So keep that in mind. Obviously, as I said, these devices are everywhere because they are so convenient, and as we know, convenience very often is the enemy of security, right? And there have been many stories about IoT devices being hijacked and being used for denial of service attacks, that kind of thing, right? So security is a big issue when we're talking IoT. So keep that in mind, and that's why I wanted to have this slide here up front. That IoT and security is something that has to be thought of as you get into an IoT project and all of that stuff. In the speaker notes, I'll have some links, some white papers, so that you can read up on what is going on when it relates to security and IoT. For this session, we will be using Raspberry Pis. And a Raspberry Pi that's the actual size. It's really small, it's tiny, right? And Raspberry Pi is a device, it's a computer. It has its origins from the UK, where it was devised basically as a tool to help schools have very inexpensive computers. That's the background for Raspberry Pis. And we can use them because they're so small and because they're so cheap, we can use them everywhere. And if you think back to that list of things that I have in my house, I probably have 8 or 10 of them running, doing all various things. Those are the specs of the latest model of the Raspberry Pi, right? So, and as you can see, when I say it's cheap, it's $35, right? That's what it costs to get a Raspberry Pi. And this is how powerful it is. You won't be launching the space shuttle with this, but it has more than enough computing power to do pretty much anything that you want to do with such a device, make it connect to anything that you want. And obviously, Raspberry Pis are not the only ones that make the hardware. We have Arduino, and we have Particle. Particle was mentioned earlier in the keynote as well. And if you now say Raspberry Pi, Arduino, Particle, I don't know these names, right? They must not be big players. So maybe this whole IoT thing is a bit of a fad, or it's something like at the edge of things. Well, rest assured that all the big players are in this IoT game right now. Microsoft, Amazon, Google, they all have their own IoT hub, where a collection of resources basically where you can make your devices send their data to, and then they will make that data available to you through their APIs and a lot of that stuff. So all the big players are into that, and I'm going to mention Particle again. Particle is really good if we want to get into IoT and you want to fiddle with that, because they make the devices and they also take care of the connectivity. My Raspberry Pis, the ones that we will be using in my session, they're connected through Wi-Fi because they are always in a place where Wi-Fi is. But if you think of a device sitting out there in the desert to do some measurements, it may not always have Wi-Fi, right? So Particle takes care of that because they offer connectivity through 3G, GMS, GPRS, all the types of connectivity. And they have APIs and they have a whole cloud hub, basically like a whole ecosphere of things that have to do with IoT. So it's a great way to get into that. So we have the Raspberry Pi. Out of the box, Raspberry Pis don't have hard drives, by the way, right? So they run their operating system and everything they want to do off SD cards. Again, makes it really inexpensive and very flexible, right? Because you just pull out the SD card, put something else in there, and you have a whole different operating system or set of applications that you can run on your Raspberry Pi, so it's very interchangeable. By default, the operating system for the Raspberry Pi is Raspbian, and it's a version of Debian, so it's Linux. And that means that the de facto scripting language, if you want to play with Raspberry Pis, is going to be Python. Most of the stuff that you'll find on Raspberry Pi and how to do projects are going to be in this Raspbian and Python. But Microsoft has a version of Windows 10 that is specifically designed for IoT, and it's called Windows 10 IoT. And what that means is that anything I can do with .NET, I can make run on a Raspberry Pi. You have your choice of operating systems, right? You are not tied to Linux if that's not your thing. If you'd rather stay in the Microsoft space, then you can do that too. And we will use both of these in this session. Thinking back to the definition that we said, right? It's a set of devices that are connected, and then they do something. They read sensor data, or they manipulate their environment. So with the Raspberry Pi, it's a computer, so we got the device taken care of. But now we have to bring that device into the real world, right? It has to be able to do things. And the way that is done with things like a Raspberry Pi and the Arduino is called a hat or a shield, which is something that you basically put on your Raspberry Pi, and it's specialized. Like this one, the Grove Pi Plus that I have there, the blue one, that is basically nothing but a set of connectors, right? Analog, digital, I2C, so that I can connect anything that I want to that hat. And by definition, it'll be exposed to me. I can work with that from the operating system. Right? And when I say we can connect things, there's no end to things that you can plug into those hats and then work with that, right? So there's motors, there's switches, there's gas detection, there's ultrasound, lasers, rain detection, humidity, temperature, like any kind of sensor you can think of exists, and you can just connect it to the hat and then basically work with whatever that sensor gives you. Or if it's a motor, you can drive that. Coming back to how cheap this is, right? I said the Raspberry Pi is 35 bucks. I believe it's 20 bucks for the hat or something like that. But these sensors, they range from, I don't know, a couple of bucks to maybe 10 bucks, right? So it is incredibly inexpensive to get into that. And I always call it's Lego, right? It's Lego for geeks. It's a lot of fun to get into. The other one, the Grove Pi hat, is one that we will use in a demo. This is another hat, the Sense hat. It comes out of Europe, and it has been in space. It's been used by the European Space Agency to do some research in space. This one is nice because it has sensors built onto the hat, so I don't have to go out and get them and connect them. And it has a very nice 8x8 LED so that it can give me feedback on whatever it is that I'm doing with that Pi, right? So it can give me some information back. So if you plug that into the Raspberry Pi, that's what it looks like, right? The bottom there is my Raspberry Pi. On the right-hand side, you see the network connection and the USB ports, and then the hat is on there. That's what it looks like. All right, so we have a device. The device can do things. It can work with the sensors, or it can drive things, but it still has to connect to something, right? It has to send the data that it collects to something, or if it needs to receive instructions, the instructions have to come from something. And if we're thinking FileMaker, then the best way to do that is through the brand new Data API. To give you a very quick primer on the Data API, in case you haven't seen too much of it, The tool, the screenshot here comes from a tool called Postman, which is a great tool for testing any kind of API, really. So it lets you put your requests together and then see what you get back. And the data API, again, very quick primer, it works like this, right? So you have your server here, and then whatever comes after the V1 is what is called an endpoint, right? So and all of that is described extremely well in the FileMaker Server documentation. But so basically, you construct a URL, you give it an HTTP method, in this case it's a post, and then you make sure that your headers and your body are properly populated so that you know what it is that you're sending. And if you do that, you will get back a response, and the response will be in JSON format. This particular request is a login request. When I do that, I'll get my token, the long string that you see there, and then I can use that token in my follow-up requests. And this is an actual call that we will be using in the demo, right? So I have my server, my URL. I'm talking to a FileMaker file called sensehat. A layout is called sensehat as well, and the endpoint is records, because what we're doing is we're sending a record to FileMaker Server, right? The fields will be these. There'll be 3 fields: temperature, humidity, and pressure. The values from that will come from the sensors in the Raspberry Pi, right? So we will instruct Raspberry Pi, do a reading on your sensors, and then construct this, send it over to FileMaker Server. When FileMaker Server is happy with it, it'll give us a response that everything was fine, and the record ID of my new record. So in essence, under the hood, that's exactly how the Raspberry Pi will communicate with FileMaker Server. As mentioned, we have our choice of operating system, and by the choice of operating system, we have our choice of scripting or programming languages. For this first demo, we will be using Windows 10 IoT on the Raspberry Pi, and the code will be C#, so it'll be .NET based. So you may think, well, I don't know any .NET, or if you have a .NET developer, what does that .NET developer know about the FileMaker Data API, right? So what's the combination of those two? How do you consume or work with the Data API if you're a .NET developer? The good news is that you don't really need to know all that much, right? So that example, the Postman example that I gave you, you don't need to know all the ins and outs, because this community is extremely great. If you go to GitHub and you do a search on FileMaker Server Data API, you will find any number of pre-built wrappers around the Data API. And what those wrappers do is basically they expose all the functionality from the Data API, but in a language that a .NET developer understands, right? And there's wrappers like this for JavaScript, for Python, for any PHP. So basically, anybody who knows a little bit of .NET can just use this library. It's open source, so it's free, and then use it to make the calls. And I'll give an example a little later. Obviously, if you write code, you have to have something to write that code in, right? So the actual tool that you use to write your code. And again, there it's free, right? Which is one of the big messages I want to deliver today, right? So these devices are cheap, the sensors are cheap, and to get going with it, it doesn't cost you any money as well, right? So writing the code is, in essence, it's free. Because there's a very good, very Visual Studio Community Edition for Windows and the Mac version. In case you haven't followed anything around Visual Studio, there's an excellent Mac version of Visual Studio around. What it all comes down to is that all you need really is a little bit of a desire to tinker with that. If you want, then it's not going to cost you any money to get going with that. So this is what it looks like from the FileMaker side. All right? So this is the file that is hosted. The file is hosted on AWS, so it's in the cloud already. And the Raspberry Pi sits in my office in Toronto. The server is, I think, in Virginia, somewhere like that. And basically, the Raspberry Pi, this particular one, will read its sensor data and send it to FileMaker Server every 2 seconds. So you can see the 3 readings: the temperature, the humidity, and the pressure. As well as sending that data over to FileMaker Server, it also instructs FileMaker Server to run a script. Right? Because part of the Data API is the ability to run scripts. And I'm running a script to calculate basically the gap between this record and the previous records. So that I can do a quick search to see how many times did it skip, right? Because it's supposed to send data every 2 seconds. And I can very quickly do a search to see, okay, when is my gap larger than 2 seconds? And figure out why that happens. The actual code to run this from the Raspberry Pi with the SenseHAD is on GitHub already, but I will release it after this session, so you can just download and take it apart. When you look at the code, actually we will do that right now. I don't intend this to be a masterclass in C# or anything .NET, but I want to show you how easy it is to do this. So you have to bear with me. If you're not familiar with C#, don't worry about it, because there's really not a lot of C# that I want to show you. The whole code that runs on the Raspberry Pi to read from the sensors and send it over to FileMaker Server is in total, it's about 250 lines of code. So it's not a lot of code, and that includes all my comments and all my white space. If I boil it down to the core essence of that code, there's probably, I would say, 30 or 40 lines of code to make this whole thing work. That's how easy it is to make this happen. So in my code, I basically create a FileMaker Server instance, which in C# looks like this. And this code basically, that's straight out of that library, right? That people can download from GitHub. That's how easy it is. I basically say, okay, give me a new FileMaker Server. It's at this address. I'll be using this account, this file, and this layout. That's how I set up the environment to do the talking to the FileMaker Data API. And there on line 96, where it says token equals await FileMaker Server authenticates, that's one line of code to do that whole authentication dance, right? So this thing that I showed you in Postman is rolled up into that one line of code, right? So when I said the .NET developer doesn't need to know too much about FileMaker Server, that's exactly what it looks like, right? He only needs to know is that use this line and you authenticate against FileMaker Server. A little later in the code, we basically have the 6 lines there inside the try. The first 3 are instructing the hardware to do a reading, right, of the sensors. Basically, update your sensors, do an actual reading. And then the next 3 are basically just storing the result of that in a variable. And those are the ones that we will then be sending to FileMaker Server. In communicating with the hardware, that's it. That's as simple as it gets. This is a little longer, but it's really repetitive, right? At the top, all we do is we use that library to say to FileMaker Server, create me a new record request. And then we fill it with just doing the request add fields, the name of the field and the value that we're sending over, right? So we do that for all the fields that we want to have included. At the end, we also say to that request, add a script, right? And this is the name of the script that we will run. And then we do the request execute. So in C# code, that's all that is required to basically do this, right? To construct that URL, pick the right HTTP method, create your body with the proper JSON that FileMaker Server understands, and then interpret the response that you get back from FileMaker Server. So all of that you see here in Postman is rolled up into this. So for the .NET developer, that's as easy as it gets. These screenshots of the code, that's the essence. That's all there is code-wise to making that Raspberry Pi communicate and send its data over to FileMaker Server. You have the Raspberry Pi there, and this is the actual, like the workflow, if you will, that the code goes through, right? So when the Raspberry Pi starts, it reads its configuration file, and the configuration file contains the name of the server, the name of the file, that kind of stuff, right? So, and then it goes into a loop and runs every 2 seconds. The first thing it does is detects whether we have a valid token, right? Have we already logged in to FileMaker Server? If we don't, we will log in so that we have a token that we can use. If something goes wrong with the authentication to FileMaker Server, all of the LEDs will light up in orange, right? So that's my visual feedback that something is wrong, and I can tell by the color, because we'll use a different color otherwise, I can tell by the color that my error is in the communication with FileMaker Server and the failure to authenticate. If we have a valid token, then we'll basically every 2 seconds update our sensors, basically get a reading from the sensors, and we will send that off to FileMaker Server, and you just saw the code on how we do that. If something goes wrong with either talking to the hardware or sending the stuff to FileMaker Server, all the LEDs will light up in red, right? That's, again, my visual clue that something is going on, so I can go to my FileMaker file, see when the last thing was happened, maybe reboot the device or anything like that. Now, if all goes well, then one green LED will light up, right? And it'll walk. So the next time that it does, the next iteration through my 2 seconds, it'll light up a different LED so that I can see by the flashing on and off of the LED that it's working fine. And that's what it looks like in real life, right? So It'll do the reading every 2 seconds, and every time that the LED goes on, a new record gets sent to FileMaker Server. From my device, sitting in Toronto, to my AWS server, sitting in Virginia. I can stare at that all day, I don't know, but... All right, the second device that is also in my office, this one uses that Grove Pi hat, right? The one that has all the funky connectors, right? So everything that's on that hat, the white thingies, those are connectors. Depending on what kind of sensor I get, it's maybe a sensor that requires an analog connection, some may require a digital connection. I can just plug them in there and away I go. This particular device has 2 sensors plugged in. I have a sound sensor and a light sensor. Right? So, and this one collects its data every second. That was just arbitrary on my side, but this one will send its data to FileMaker Server every second. What that means is I have 2 devices in my office, both doing their own thing, reading their own sensor data, and sending it off to FileMaker Server to that same file. So think about that, right? So these 2 devices make 90 requests per minute to FileMaker Server. And they've been doing this since forever, since we had the first ETS builds of 17 with the official data API. And in my experience, it's both extremely fast and extremely stable. I'm very impressed with the data API. If you come to my server session tomorrow, we'll dig a little deeper into the difference between the data API and the web publishing engine. But I'm extremely happy with the data API. The code for this one is on GitHub as well. I will release it after the session, so you can download it, play with it. But in essence here too, the total code for this particular one is very, very similar to the one that I showed you with the SenseHat, right? So it really comes down to maybe 30 lines of code to make this work properly. So I'm making requests to FileMaker Server 90 times a minute. I'm creating new records as we go along, and you can imagine that's a fair amount of data if you add it all up during the course of a day. So we may be thinking, well, this data API is not free, right? It's part of your license, but you have a yearly allowance, right? So how does that come into play? Well, the good news is that for what I'm doing, I'm basically reading data from my Raspberry Pis and sending it up to FileMaker Server, and pushing data into FileMaker Server is free, right? That doesn't move the needle on your usage. It's only when you request data from FileMaker Server that it gets metered. These 2 screenshots I took about 10 days ago, and at the time, my 2 Raspberry Pis against that particular server had been running for 72 days. So you can see how many records it created in 72 days, right? So if you're really good at math, you will have figured out it's like 8.5 million records. Now, if I go to my FileMaker Server, on my dashboard here, I can see how much of my allowance that I have already used, right? And you can see I have used almost 900 megabytes. How is that? Because I'm just pushing stuff into FileMaker Server, and that's not metered, right? That doesn't go against my allowance. The thing to consider is if I take that, close to 900 megs, right, and I divide that by the number of calls that I made, number of records that I created, it comes down to just over 100 bytes per call. And I put an asterisk next to it because the actual number is closer to 96, I believe. And that's the response that you get from FileMaker, right? Every time that you make a request to, say, create a record like we do, FileMaker sends you a response. The response is in JSON and contains the record ID, any error numbers of that stuff. And since that is something that FileMaker Server sends to you, it does get metered, right? It does get used. Now, probably going like, holy crap, I may be running out of allowance. The screenshot that I showed you is for a very simple 5-user license, right? And my yearly allowance is 120 gigabytes. If I take my 120 gigabytes and I divide it by 103 bytes per call, it means I can do 1.2 billion calls in a year before I run out, right? So if I narrow that down to what I can do per second, I would have to create 37 records per second to run out of my allowance. I don't know about you, but I don't have systems that create 1.2 billion records in a year. And that's with a simple 5-user license, right? If you have, say, a 20-user license, your allowance is much, much bigger. I was a little surprised at the number, at seeing that I was using up some allowance. But if I look at it at the rate that I'm sending data to my FileMaker Server, I will not have used up the allowance for one user. It's like 20% of one user's allowance if I keep my Raspberry Pi sending data over at the rate that they're doing it, which is 90 times a minute. The metering of the data API is clearly not something that I would worry about. Up to this point, we've been talking about sending sensor data up to FileMaker Server, right? So, and if you go back all the way back to the definition of IoT, we're talking about devices that are connected and that either collect sensor information and inform you of what they're measuring, but they can also manipulate their environment, right? So you can make them do things. And the simplest example for that is driving motors. For driving motors, with the Raspberry Pi, I have yet another hat. The blue thing you see in the screenshot is an Adafruit's motor hat. This one can drive up to 4 motors, but you can stack them. I think the limit is something like 64 motors from one device. You have different kinds of motors. You have your regular DC motor and stepper motor. So it kind of depends on what it is that you want to drive, but those devices are very easy to make things happen. This particular example, these fields that I have on my layout here, that's sort of like the typical information that a motor needs to run, right? You need to know what the frequency is. The motor number is 1 through 4 because that particular hat has 4, I guess, motors it can run. So I need to tell which one I'm talking to. And then you can say, well, run the motor forward or backwards, depending on what you want to do. Do it for this long at this speed, right? So that's your typical motor information that you would need to send to the device so that it can do what it needs to do. And you can keep that in FileMaker, right? You can make that part of your workflow. In your workflow, you get to decide how that motor runs, right? What it really means is that the device can remain as dumb as it needs to be. There doesn't need to be any logic on the device if you don't want it to. All your logic can remain in FileMaker, right? And you as a developer, you get to decide what it needs to be. You can change it at will, and you don't have to redeploy to the device because the device will basically just read from FileMaker, right? It will get its instructions from FileMaker simply by calling the data API to say, okay, what is it that I need to do? It'll read it and execute it. All right, so for this particular one, we will use Linux, right? We will use the Raspbian operating system that comes with the Raspberry Pi, and that means that the code that we need to write is going to be Python. And just like what we talked about with the .NET thing, right? We know that in order to talk to FileMaker Server, to get the instructions on what our motors need to do, we have to go to the data API. So what does that look like if I'm looking at Linux with Python? How do I communicate with that data API? And again, like I said, this community is great because as soon as FileMaker Server was released in May, the Server 17 with the official data API, people have created libraries. And as you can see, and this is the Python library from David. I communicated with David in preparation for this session. Very helpful, and it works like expected. And again, here the message is that if you know a little bit of Python and you want to dabble in that, or you have a Python developer on hand that you want to hand this off to, they don't need to know too much about the data API. They just need to know how the library works, what calls to make, and they can just go ahead and make it. To write your Python code, again, you have to have an IDE to write your code in. You can use Microsoft's excellent and cross-platform coding environment, VS Code, which is not Visual Studio. It's in essence, it's a text editor on steroids. It's really good. There's any number of IDEs out there that give you the ability to code in Python and have the full feature set with code completion and syntax checking and all of that stuff. I just use VS Code and it supports Python. So in essence, just like with the .NET stuff, you don't have to spend a lot of money to get there, right? The device is cheap, sensors are cheap, and writing the code is in essence free. All you need to do is spend a little bit of time on it, or find a developer who's willing to do that for you. All right, time for me to get up here. As I was thinking, what demo can I put together for something that has motors and that I want to drive and show you how to do that, right? So if you were lucky enough to be around about, say, 18 years ago, DEF CON 2001 and 2002, you may have seen FishMaker Pro. Now that we have the data API, it's time to bring him back. I give you Billy Bass. Billy Bass at the time, this was done by Rich Colombre and his team over at the support group, and they were using a serial plugin to make Billy Bass basically speak whatever was in FileMaker. The serial plugin was from Troy, who has a vendor booth, right? So it was time that we modernized Billy Bass a little bit and make him do things in an IoT fashion. When they did the original one with the serial plugin, it had to be connected to the computer, right? Because all the communication went through the serial bus. Now that we have IoT, Billy Bass can be in Seattle, I can be in Boston, and I can still make Billy Bass talk whatever I needed to say, right? So without further ado, I give you Billy Bass. I did say it was almost 20 years ago, right? So he has suffered a little bit. So, and I will show you just like I did for the .NET stuff, I will show you the code workflow here, and then I'll show you the FileMaker file as well.
Oh no. Not you guys again, not another DevCon.
So, actually, why not look at the code right now? And let me jump out of here. This is that SenseHat file that we just talked about. And you'll have a copy with the file with the materials here as well, right? So, as you can see, this is my SenseHat. And if all goes well, we see that it's merrily ticking away, creating a record at the rate of once every 2 seconds. This is the Grove Pi one. There we go. And this one is creating a record at the rate of 1 every second. It's happily doing that. Now, here's Billy Bass. A Billy Bass like that has, depending on the model, has 2 or 3 motors, right? One to turn the head, one to move the mouth, one to move the tail. So it's a great one to tinker around and play with and make it do things. Obviously, I wanted to make it say whatever I wanted it to say. And it means I have to type something in FileMaker. FileMaker's database, it stores what I need to do. How did we make this one work? And this is, personally, I think, obviously I made it, so I think it's great. I think it's a really good example of how well FileMaker integrates. So what we do is we type our text into FileMaker. That's the text that will be spoken. We actually go out and talk to the AWS Poly API. AWS Poly is a text-to-speech API that is available from Amazon, right? So we send the text over, they send back the MP3, right? So the synthesized text of what it is that we want to say. And we can basically get it, we can pick our language, and then per language you have a number of voices, a couple of female voices, a couple of male voices, child voices, that kind of thing, right? So you get to pick what it needs to be, and then as we send that to Poly, it'll use that to use that. Now, the other thing that we get back from AWS is what they call visemes. It'll tell you basically what the mouth position needs to be at any time during the speech, basically, right? So using that, we can then decide, and that's exactly how we do it. We know when to drive the motor that moves the mouth. We know for how long it needs to do, if it's an open syllable or a closed syllable, all of these things, right? So fortunately, I have 2 daughters. One wants to be a marine biologist, and the other one studies linguistics. So they were great help for me to... I hadn't heard of visemes. I did not know what these things were. But that's basically how playing the sound is easy enough, right? That's just a matter of piping the MP3 through the speakers and you're done. But moving the mouth and moving the head, we had to decide on when to do that, and that comes from Poly through the visemes. The Raspberry Pi, it's actually doing it right now. I can't really see it, but it queries the data API twice per second. Every half second, it basically asks FileMaker, do you have something for me? Do you have something for me? And again, this file is hosted on an AWS server, right? It sits somewhere in Virginia. I'm here, the Billy Bass is here. There's no connection between my machines and Billy Bass, right? The only connection that Billy Bass has is this Raspberry Pi right here. And that one is connected to the internet. It's wired, but it could be Wi-Fi as well, right? So totally disconnected. I can walk away from here and go to another session and play Billy Bass from there, because it'll just pick it up from through the internet.
Hi, my name is Andrew Lee Cates. When I get going, you really have to fasten your seatbelts, because there is a lot to cover and you are standing between me and my coffee, or Red Bull, or whatever the heck it is that makes me talk like this.
And if I want to be a little disrespectful...
I am a fish, and my name is Dominic. Is there a FileMaker developer in the room?
So all of the code that we're using to make this work will be in the sample file, and you can download from GitHub. Probably the most difficult thing was actually the integration with the Amazon Poly API, because it requires a very specific signature to happen. And again, with the help of the community, I was able to find the code and adapt it to make that work. I can't say it enough. We have a great community, and I personally will do anything I can to maintain it like that. Obviously, since we have a platform, this file is also accessible through my FileMaker Go, right? So I can walk around here and browse through my records and make Billy Bass speak or just turn his head and do all of these kinds from my cell phone, which is the essence of making this IoT, right? So we can use any feature that we have in the FileMaker platform and integrate it all the way to what is referred to as the edge, right? This would be the edge. This is making something happen in the real world, right? Be it getting a reading or making something move. So as I mentioned, the code for that is going to be on GitHub. I will release it right after the session. This is the Python code. And again, the number of lines of code to make this happen is way, way under 300. And that's largely because I make so many comments in my code, right? So it really, if I want you to walk away with one thing that you learned today, it's how easy it is to get into these things. And this is the total flow here for the code. Very similar to what I showed you with the flow for the .NET code, where it's sending the sensor information to FileMaker Server, right? So it's a Python script. Python script is just pure text. When I fire it off, it'll go into a loop, and it'll loop every half a second. It'll go through this whole iteration. The same thing, right? It'll figure out whether we have a token. Have we logged into the data API? Do we have a token that we can use? And if so, it will try to see if we have something that we want to read. And in FileMaker, it's as simple as having this checkbox, right? That's my field that it does a search on. All it does is does a search for any record that has this flag set. If we do two things. Well, it's actually in the same request. We download the actual MP3 down to the device, right? I could have made the device talk to AWS and do all the text-to-speech generation from there, but I didn't want to do that. I wanted my device to be as dumb as I could make it, right? I wanted all my code to be in FileMaker so that I have control over it and I can change it at will without having to push updates to my device. For me, that's crucial, right? Because these devices are cheap. You can almost think of them as throwaway, right? You want to be able to pick one, put it somewhere, and do its thing, right? You don't want to have to configure it ahead of time and do that 10 times if you have 10 devices that you want to put around your perimeter and make it do things, right? So for me, the important thing was to keep all the logic and all the code in the FileMaker file so that the device just has to read from FileMaker and understand what it needs to do. We download the MP3 down to the device, and then we play it. We also get the vizims, right? The JSON vizims, and then we basically just parse that and read through it as we're playing the MP3, as we're playing the audio. We were talking about the metering, the data API usage, right? And clearly, we're not pushing stuff into FileMaker. This is where we read from FileMaker, right? So every time that we ask FileMaker, do you have something for me, it'll basically move the needle a little bit on our data API usage. And you may be wondering, but yeah, downloading these MP3s, they're not huge. I think a typical MP3, if it's say 5 to 10 minute audio clip, it's going to be maybe 100K or something. So it's not huge, but it's 100K. The thing is, with the data API, when you make a call for a record that has a container, you don't actually get the container content right there. You get a URL to where that file is. And then you basically make a separate call. So the size of what's in your container doesn't count against your usage for the data API, which is the great news, because this could be multi-megabytes worth of stuff that I put in a container, and I'm not getting charged for it. I guess that's the essence, right? You do get charged for getting the records, including the URL of where your container data is, and then you download it separately. So the way that FileMaker has done this is incredibly efficient, given the allowance that we have to work with that. So if we find a flagged record, we will download the vizim data, we will download the MP3, we will play the MP3, we will move the head, basically drive all the motors that we want to have done. When we're done with it, we will actually talk back to FileMaker Server to say unflag this record because we're done with it, and also update the notes field to say this is when we, basically a timestamp and the word done is what we're sending back, right? So it's a full I guess it's a full circle, right? We read from FileMaker, FileMaker tells us something that we need to do, the Raspberry Pi executes it, and then the Raspberry Pi says, I'm done, you can, and updates the records, and it's completely finished. Now, if we do find something that we want to play, we will halt the loop that typically happens every half second, right? We will wait until we're done playing with the audio, until all the motors have stopped before we go back and see if there's something else to be done. Now, we do this twice every second, right? So twice every second, we make a request. We do an actual find against FileMaker Server, right? And I could make that interval way shorter, because doing a find request to the data API is wickedly fast, right? So I'm not even close to running into conflicts where FileMaker isn't done with the previous find before I ask it to do the next one. That fits in with what I was saying earlier on how impressed I am with the data API. I'll take plenty of questions. If you have any questions on anything that I've shown, I will release the file. The file has the integration to Poly for you as an extra. I'll open up the GitHub repository so you can download the source code and just look at it, right? I don't expect you, unless you happen to be a Python or a .NET developer, to work with that right off the bat, but do take the time to just look at it, right? Just to see how simple and elegant it is to consume the data API from these environments and what it can do for you, especially what it can do with these simple and cheap devices, the IoT stuff. All right, so I thank you for that.
Thanks, Wim. That was really interesting. Just curious, with having it poll FileMaker Server, every twice a second, obviously if you had a lot of devices, that could add up. Would it be possible to structure so you only reached out and push the information to the device when you had something for it to do?
So yeah, the question would be, can we turn the logic almost around a little bit, right? So that the device wouldn't have to query FileMaker every half a second, but right. If there was something to do, that it would talk back to the device. The short answer is yes. What it would mean is that we have to move some of the logic to the device, okay. But that's entirely doable because these devices, like I said, it runs Linux, right? It runs Windows 10 IoT. It's that simple to make them into a smallish web server. Right. And the web server could be listening for anything that we can do, right? So through putting it in listening mode, I guess, right. Is really simple to do with all the tools that are already available through the OS on these devices. So, okay. So yeah, entirely doable.
Okay, thanks.
Thanks, Jonathan.
Oh, that was great, thanks. How do you, if you have multiple IoT devices, how do they identify themselves to FileMaker? Is it a serialization in a config file or something like that?
Basically, the way that the devices call the data API is they have to use an account. There has to be a FileMaker account that they use, and obviously the account is limited to just using those, but that's how they do it, right? So, and I'm using a config file.
Yeah, so each device could have its own account and
not
logs.
Necessarily. They can all share the same account if you wanted to, but if it's important to you to know which device it is, then you could give them each a separate account. Now, since it's hardware, typically there's an identifier that you can read hardware-wise. So you could send that along as well to identify what device it is, or even use the IP address. So there's plenty of things that you can send up from the device to make it uniquely known to FileMaker Server which one it is. But for authentication purposes, it's got to have a FileMaker account.
Do you have any sense or information on how the data API works in the environment in FileMaker Server? So if I had a user doing finds every 2 seconds, I would see that performance in FileMaker Server. And if I had a lot of users doing that, eventually I would see some of those finds being stacked up. Basically, do you see any performance hit, or do you foresee seeing any performance hit when you have IoT devices like this hitting the server frequently in the data API, and then maybe also having users working on that same server? Or do you need a dedicated server just for these IoT devices?
It's a great question, and to start backwards, you wouldn't need a dedicated server just to handle the data API or IoT stuff. But you have to you would have to think or look at the whole picture, right? And clearly you have to build your server or choose your server with its total load in mind, right? So you can't really have a server that is currently serving, say, 20 users and throw a load of data API or IoT stuff at it if it's already sort of marginal in its performance, right? So you would have to spec your server so that it can handle the extra load. Now, the finds that you do, like what I'm doing every every half a second to FileMaker is slightly different than when a FileMaker client would do it, right? If a FileMaker client does a search and there's a found set, there's a communication between FileMaker client and FileMaker server that you don't have with this kind of stuff. That whole notification scheme that FileMaker Pro client and FileMaker server have is less of a factor when you do it through the data API from a device like that, because you don't have that persistent connection that a FileMaker client would have, Go or Pro. Less painful, let's put it this way, or there's less overhead in doing it this way.
So you wouldn't have to maybe apply the same, one user in FileMaker Pro does not equal one user in Data API.
No. Yeah.
I guess follow-up question then, would it make sense in some cases to have a FileMaker Pro user do a data API call for a find rather than doing a regular find in some cases to save overhead?
I personally wouldn't do it that way, because if you make a FileMaker Pro client do a data API call, you still have to work with a response. The libraries that I've used, the .NET and the Python ones, they do it because it's built in, so they can look at the JSON that you get back and figure out what needs to be done. If a client, a real FileMaker client, needs to build a found set and you make a data API call, you don't get a found set back, right? You get information about the found set. You would still have to then parse through that and then still build the found set. I think end to end, you're probably going to be better off just making the FileMaker client do a native find.
Thank you.
You're welcome.
Are you doing anything to secure the device since it does have to store the FileMaker account credentials?
A great question, absolutely. Absolutely. I'm using the OS features for that, right? Clearly, in the simplest form, you would have a configuration file that holds a couple of lines of information, like what's the DNS name of my server, what's the name of my file, what's the account to use, right? So you would use whatever the operating system provides you as like credential storage or encryption, anything like that, so that it's not pure open text that anybody can read if they get their hands on the device. A really good question, because these devices, because they're small and they're put into places that are by definition physically sometimes less secure than where you put your servers or your workstations, that's something that you have to keep in mind, right? So these devices may get stolen or they may get lost, right? So you don't want what's on it to be easily readable, I guess, right? So that's a great question.
Thank you.
You're welcome.
Yeah, what are your thoughts on some of the other protocols like MQTT? Have you checked and looked at what's going on in that part of the world in terms of LoRa and all the sensors that are getting ready to come on board in that protocol as well?
Short answer is yes. Anything that has to do with these kinds of communication protocols, and not just necessarily communication protocols, but queuing mechanisms that some of them bring as well, right? So yes, I personally look at that all the time and see what's up, what's available. It's
any thoughts on the performance of any one that stands out in terms of millions of sensors at one time? We found that we've been dealing with a large carrier. They drag us down this huge pipe, right? Yep. And they drag us down some, for example, MQTT, where we've got multiple and millions of devices. Have you guys done anything in that volume?
No, we haven't done anything in that volume, but clearly because of the volume, performance and amount of data that you transfer is a concern, right? Because you want to make it as small and as lightweight as you can. I mentioned some of these devices may live somewhere where there's very poor connectivity, right? So, and there too, even if you don't have the massive volume and millions of records that you're sending, just because of the limitation that you have or the constraint that you have, that you can't really rely on speed, so you want to make your transmission as short and concise as you can make it. So these protocols, some of these are great for that, right? Where they offer you compression and all the other things that you would use.
Thanks.
You're welcome.
I suppose you got the two IoT. One is doing get and one is doing push, not post. But they all have to write on the same page. Is it possible that the FileMaker handle that at on real time online?
Let's see if I understand the question correctly. You're talking about two different devices that interact with FileMaker.
Yeah.
The same record, the same layout.
Yes. Yes.
I don't have any big concerns about that. The only thing you would have to keep in mind is, just like if this were two actual users, is that you shouldn't step on the other user's work, right? So if there's any record locking involved, or if you want to make sure that you have the latest data, you would check for that. But concerns about doing this simultaneously, no. No big concerns.
That means that one IoT give you data, and you based on this data to ask the other IoT to do something. So keep on doing that.
Yeah,
That's my mean.
Yep, exactly. I don't have any big concerns about that.
Thank you.
You're welcome.
So you've obviously acquired a lot of devices and sensors and things. If you were just getting started today, what would be on your shopping list?
The Raspberry Pi with that Grove Pi Plus hat that I mentioned, simply because it allows for any number of connections that you can do. And if you go to Amazon, they actually sell kits that come with that. You can buy a Grove Pi hat plus something like 10, 15 sensors that do the basic stuff. So that's what I would do.
Awesome. Thank you. This was great.
Thanks, Greg. All right. Go ahead.
If you've done a lot of work in Arduino and you want to move over to Raspberry Pi, do you have any recommendations between the Windows versus the Python approach? Does it make much difference, do you think?
It doesn't really make too much difference because the code will execute. If you have, say, Python code for Arduino, you may have to make some changes because the drivers for the sensors may be slightly different, but the majority of your code you can just reuse. So switching between the manufacturers of these devices is not a big deal. All right, thank you.